Imagine an engineering student debugging the logic sequence on a complex robotic arm. They run the simulation, and the hardware glitches mid-movement. To find the error, the student pastes their code into a standard, commercially available AI chatbot. Seconds later, the AI spits out a beautifully structured, highly articulate explanation of exactly where the code failed. There is one problem. The logic in that perfectly formatted answer is completely wrong. This is known as model overconfidence. Standard large language models are statistical engines optimized to generate text that sounds human and persuasive. They are not calculators of objective truth. In high-stakes STEM education, a machine that hallucinates hardware architecture actively damages the learning process. It gives the student a false sense of security built on flawed logic. Humans are psychologically wired to trust confidence. When an argument is eloquent and well-structured, we naturally assume the underlying facts are accurate. Because the AI sounds so authoritative, students build a dangerous habit of accepting its outputs at face value, completely skipping the essential step of verifying the work themselves. We often treat these conversational agents as reliable sources of information, when they are actually calculating word probabilities to predict a likely sentence. This statistical guessing lacks the grounded reasoning required for teaching. Relying on raw, open-ended language models inside a classroom carries an inherent risk because their architectural design is inherently unpredictable. A warning label on the chat interface cannot fix a design flaw. To be useful in a classroom, the model's internal decision-making process must be structurally constrained to prevent factual errors. Researchers at the 2026 NGNDI conference presented a structural fix for this issue. A study by Chen and colleagues detailed a method to strip away the AI's ability to hallucinate entirely. The first pillar of their solution is a system called Retrieval Augmented Generation, commonly known as RAG. This diagram shows how RAG interrupts the standard process. Instead of guessing, the system intercepts the user's prompt, rerouting it into a closed-loop database of peer-reviewed textbooks. When constructing an answer, the AI is mathematically forced to use only factual data from this silo. By forcing the model to cite specific, vetted sources, RAG acts as a hard structural failsafe. It completely eliminates the machine's ability to invent facts from thin air. Correct facts are the foundation, but a tutor also needs a strategy. Researchers Call and their team focused on programming the specific behaviors an AI needs to be an effective teacher. An AI that simply retrieves and hands over the correct answer is a terrible instructor. It completely bypasses the student's own critical thinking process. Researchers solve this through fine-tuning. They train the RAG-secured AI to adopt the specific behaviors, patience, and pedagogical rules of an expert human tutor. This diagram shows the difference in behavior. Instead of providing an instant answer, the fine-tuned system assesses the knowledge gap, asks Socratic questions, and guides the students step by step with rule-based hints. Combining the factual constraints of RAG with the pedagogical rules of fine-tuning turns a volatile language model into a reliable, effective teaching tool. When we apply this engineered AI back into that initial robotics scenario, the interaction looks entirely different. The tutor securely identifies the logic flaw in the hardware sequence and guides the student toward the solution without ever risking a plausible but incorrect explanation. Grounding deep neural networks with retrieved, symbolic educational knowledge guarantees that the AI's explanations remain faithful, rule-based, and completely auditable by human experts. By standardizing these safety protocols, researchers have established a method for deploying AI tutors that consistently follow technical rules, making high-quality instruction more accessible to anyone with a terminal. The goal of AI in the classroom is a system built to cross-reference every claim against a verified source of truth. The real revolution is engineering a machine that knows exactly where to look.